objectives. First of all, we should know what the key points are for a homologous series, what a hydrocarbon is, general formulae of a couple of organic compounds, alkanes and alkenes. Look at what saturated and unsaturated means and see a couple of examples, and recognize different types of formulae. You've probably come across molecular formulae already, empirical formulae, but let's just recap what structural means, what displayed means as well. And then we'll finish off with what fractional distillation does. Why is it used to separate crude oil? How does it do that? And then we need to know the key points in fractional distillation. All right, so let's start off then with homologous series. If that's the first one, let's have a look. Yep, homologous series, basically a series of compounds or family of compounds really, and these are the key points. Look, have the same general formula. Each member of the family differs by a CH2 unit, and they have similar chemical properties, and there is a trend in the physical properties of these compounds also. Now remember the words similar chemical properties, not the same, and also remember the word trend in physical properties as well for the exam. Okay, so several points there. Right, a hydrocarbon, just by looking at the word hydrocarbon, you notice hydrogen and carbon make it up, and basically it's a compound that contains carbon and hydrogen, but the key word is only. For the exam you have to say only, carbon and hydrogen only. Okay, right, next we'll look at the general formulae. Alkanes, CnH2n plus 2, for example butane. Alkenes, CnH2n. There's less hydrogens in here. Right, so for example butene. Let's have an example. One example there, like butane. If you're asked to do write a formula for an alkane and they gave you the number of carbons, for example they gave you say 7 carbons, then you could say C7 and then H2n plus 2, 2 times 7, 14 plus 2 is 16, so H16, and that would be heptane. Okay, so you could actually quite easily work out the formula of any alkane or alkene using the general formulae. Right, next. Types of formulae. Let's use butane and just very briefly describe what these different types of formulae are. You're all familiar with molecular, and butane you know is C4H10, and that would be the molecular formula, so however many atoms of the different elements that are grouped together like this. Simply, empirical formulae, the simplest ratio of the atoms, so if whole number, so if you divide this, let's say by 2, you'd get C2H5. You can't really break that down anymore without keeping whole numbers, so that would be the empirical formula. Okay, the displayed formula next is basically showing all of the bonds, all of the covalent bonds. So for example, if you've got butane, 4 carbons, 1, 2, 3, 4, and remember every carbon has to have 4 bonds. So 1, 2, 3, and there's one there. If I put the rest of the covalent bonds in for butane, then we'll see where the hydrogens and how many hydrogens there are. Here we are. Put them in. In the exam, you should put the hydrogens in. Okay. Right, and you notice that that is the full displayed formula. Sometimes it's called the full structural formula as well. It may be called that. Displayed, full structural, and there's another word. Displayed, full structural. I can't think of the other word, but you may get another word as well that means the same thing. Right. Structural is basically a little shorthand version of writing it, but not as short as the molecular. Let's see how we do that. The first one, you see you got CH3 there, right? So you write CH3. Then you got a CH2 and then another CH2. So CH2, CH2, and then finally you end up with this, which is CH3. And there we are. That would be your structural formula. Okay, that's fine. Let's move on. Right, what does saturated mean and what does unsaturated mean? Right, remember that saturated, alkanes are saturated and alkenes aren't saturated, they are unsaturated. Compounds containing carbon to carbon single bonds only are saturated. So for example, here we have an alkane, propane, and you notice that all the bonds, the carbon-carbon bonds, are single, so it is saturated. And you notice this one here, this is an alkene because it's got a carbon-carbon double bond functional group, and it is propene, 3 carbons. So the carbon-carbon double bond therefore means that it is unsaturated. Okay. You may also need to know the simple chemical test for an alkene. And the simple chemical test for an alkene is you add the alkene. If it's a liquid, you add a little bit of the liquid to a test tube containing bromine water, and the bromine water gets decolorized. If it's a gas, then you would bubble the gas into some bromine water, and what would happen is the bromine water would become decolorized. If it was an alkane, nothing would happen to it, it would stay brown. So remember the simple chemical test. Right, next we'll move on to isomers of butane, C4H10. Remember what the isomer definition was? Same molecular formula but different structures. And I've just drawn the carbon skeleton here, look, that's all. I could put the hydrogens in, and I'll do that now. I'll put the hydrogens in. So you recognize butane straight away. That would be one isomer. And the other isomer would be this one here. Let's put the hydrogens in. Remember that as a final check, make sure that every single carbon has got 4 bonds. Just squeeze that in, there we are. So that's just butane. And this one here, the longest chain is 3, so it's going to end in propane. And on the second carbon we have a branch, a CH3, and CH3 is methyl. Because it's on the second carbon, we call it 2-methyl propane. Okay, here are the 2 isomers of butane. Alright, let's move on to the next one. Let's look at the isomers of butene, an alkene. I've just drawn the carbon skeleton again. I won't bother drawing in the hydrogens this time, but remember that each carbon's got 4 bonds, right? So this one would be called butanene because the functional group is on the first carbon, and this one, the functional group is moved to the second carbon here, so it's called butatuene. Because the position has changed, the functional group position has changed, these 2 are isomers. They're called positional isomers. Positional isomers. The position of the functional group has moved. If you go back to the alkane, the butane, here the chain length is different. So these 2 are chain isomers. Chain isomers. Alright, let's move on. When you come back, just very briefly mention butadiene. You will go on to study butene a little bit further, and you'll find there's a different isomer. There are two isomers of butadiene. You may want to look that up in a textbook and look for Z and E isomers. Alright, and you may want to read ahead and look at that, but that's later on. It's different types of isomers, not structural isomers. They're called geometric isomers. Okay, examples of haloalkanes. Here's a couple here. Haloalkanes, one of the hydrogens being replaced by a halogen, so chlorine, bromine, iodine, etc. The length of the carbon chain, 1, 2, 3, 4, is a butane, so it's chlorobutane, and that would 1 chlorobutane, and that would be 2 chlorobutane. And again, these are positional isomers because the position of the functional group, the chlorine, has changed. Right, fractional distillation of crude oil. Why do we do that? Why do we use fractional distillation? Well, we make use of the fact that crude oil is a mixture, first of all, and all the different parts of crude oil, all the different fractions of crude oil have different boiling points. And so we can separate crude oil into its different various parts by heating it up and allowing parts of it to boil away, and then those little fractions are collected and then used. Right. So crude oil is separated into fractions because its fractions have different boiling points. Now, if we look at a very, very simplified diagram of a fractionating column, I just want to show you a couple of points on here. The first thing is that the fractionating column is at the very top, it's cool. It's cool at the top. And we have low molecular mass molecules there, low molecular mass molecules. And over here, right at the very bottom, you have the high molecular mass molecules. So remember that those two facts: cool at the top and hot at the bottom. And that would be called a temperature gradient, and you need to mention that in your exam. So mention temperature gradient in the column. Mention the word column as well. Okay, remember, cool at the top. Right, features of fractional distillation. Again, these are important points for your exam. The first thing, fractions have different boiling points, 1 mark. Boiling point depends on the size of the molecule. The higher the bigger the size of the molecule, the higher the boiling point. Temperature gradient in the column, mention that as another mark. And then heavier molecules at the bottom. That's the higher molecular mass molecules at the bottom of the fractionating column, and that's another mark. Okay, alright, so what we've done then is we've looked at homologous series, the key points, hydrocarbon, definition, general formulae. We know what saturated means and unsaturated means. Look up the test for an alkene with bromine water. You may need to know that. You should be able to recognize different types of formulae: molecular, empirical, displayed, structural. We now know why we use fractional distillation, because all the different fractions have different boiling points, so we can separate the different parts of crude oil into its useful parts. And we also know the key points to note when writing about fractional distillation in an exam. Right, and that was this little video.